name of Werner Heisenberg, one of those brilliant dudes. And he said, in fact, it's called the uncertainty principle because the idea is that you can never exactly know where the electron is.
Right.
So that
The more you know about its location, the less you know about its momentum.
so there's actually an equation that relates to this, and it's delta x times
Delta
delta
parentheses,
mv is greater than or equal to h over 4 pi. What in the world is that?
I don't know.
All right. Delta x is your position. How well do you know where the electron is within a particular number of meters,
Okay.
or centimeters, or nanometers, or whatever? And this is the mass of the object and its speed, because the electron ultimately is moving.
Mm-hmm.
This is, by the way, when you take m times v, it's actually called the momentum. And it's greater than or equal to h over 4 pi. And h, if you recall, is Planck's constant, and it is a very small number,
Yes.
10 to the minus 34th. And so what you can do is you can solve for, if you do the math, I don't know if we do you want to do the math?
Nah, let's not do
If
that.
you do the math, what you're going to do is you're going to discover that the value for delta x is usually in the neighborhood of about a meter for an electron in an atom. Now, why is that a problem?
It's huge.
A meter is like 3 feet, right? And 3 feet is much bigger than an atom.
Uh-huh.
An atom is, of course, in the nanometer range. And
If
so
that.
the ultimate answer is, it's kind of like the old joke. If you ever go to you go to a hotel and they've got this sign on the front of the door. You ever been to those hotels and it says, George Bush slept here or Barack Obama slept here, one of those type of things? Well, they have Heisenberg slept here. Maybe.
Maybe.
Because it's the Heisenberg uncertainty principle, because you
Yeah.
never know.
Right, because the
where an
more you
electron
know
might be.
about the position, the less you know about the momentum. The more you know about the momentum, the less you know about the position.
So that's probably as clear as mud, frankly.
Yeah.
But the point is that you can never know the exact.
Lukas's reagent is a solution of zinc chloride in concentrated hydrochloric acid. It is a chlorinating agent, replacing the hydroxyl group in alcohols by a chlorine atom. Alcohols are soluble in Lukas's reagent, but the reaction products, chloroalkanes, are not, so they separate from the reaction mixture as a separate layer. Tertiary alcohols react with Lukas's reagent almost instantly, so the solution turns turbid immediately upon mixing the reactants. The reactions of secondary alcohols is slower, and it usually takes several minutes until the solution becomes cloudy. Primary alcohols react so slowly that no change in the appearance of the solution is observed at room temperature. The reaction with Lukas's reagent provides a convenient test for telling primary, secondary, and tertiary alcohols apart.
I'm going to try something. I'm going to ask if you can answer my question. My question is this. What is the product? What molecule am I going to create, okay, when I add these two reagents together? The first reagent I'm going to give you is iron Fe, iron 2 sulfate, sulfate ion SO4. The second reagent is hydrogen peroxide. So what do I get when I add these two reagents together, okay? All right, I'm going to ask if you can answer my question. My question is this. What is the product? What molecule am I going to create, okay, when I add these two reagents together? The first reagent I'm going to give you is iron Fe, iron 2 sulfate, sulfate ion SO4. The second reagent is hydrogen peroxide. So what do I get when I add these two reagents together, okay? All right, I'm going to add the second reagent to the first one. And if you can see a color change take place, what is happening? Remember, this is iron sulfate, and this is hydrogen peroxide. What is this brown color here? What is this brown molecule that's actually being formed? What is this layer here? All right. Okay, so to finalize our question, what molecule is now present in this solution? Our previous solution was iron sulfate, iron 2 sulfate, okay? And I added hydrogen peroxide to that reagent.
Is obtained by adding a small amount of sodium hydroxide to a solution of silver nitrate. This gives a black precipitate of silver oxide. Then, ammonia is added to the mixture just to dissolve in the silver oxide precipitate. As a result, a complex ion was formed with silver cation, and the solution became clear and colorless. The tolerance reagent is an oxidizer. As we have learned in Wargo, oxidizer increases the number of CO bonds for molecule. The salicyl aldehyde, shown on the left, contains 3 CO bonds. After reacting with sodium dichromate, which is a strong oxidizer, the aldehyde group is oxidized to carboxylic acid, and OH group is oxidized to ketone. Thus, a 5 CO bond is observed. In comparison, tolerance reagent is a mild
We will explore it as a 4-part series. Now, there are two statements of the second law of thermodynamics. First is the Kelvin-Planck statement, which states, it is impossible for a heat engine to produce net work in the complete cycle if it exchanges heat only with bodies at a single fixed temperature. Second is the Clausius statement, which states it is impossible to construct a device which, operating in a cycle, will produce no effect other than the transfer of heat from the cooler to a hotter body. Before we establish the equivalence of these theorems, we need to define a few terms. The first among them is a thermal energy reservoir, which is defined as a large body of infinite heat capacity capable of absorbing or rejecting an unlimited quantity of heat without suffering appreciable changes in its thermal condition. Second is the concept of heat engine, defined as a thermodynamic cycle in which there is a net heat transfer to the system and net work transfer from the system. Third is the concept of refrigerator and heat pump. The former is a device which, when operating in a cycle, maintains the body at a temperature lower than that of the surroundings. The latter is a device which, operating in a cycle, maintains a body at a temperature which is higher than that of the surroundings. Hence, we just saw that the second law of thermodynamics has two statements, that is, the Kelvin-Planck and the Clausius statements. And we also defined some basic terms, namely a thermal energy reservoir, a heat engine, a refrigerator, and heat pump.
Amnesty International has stripped Myanmar's leader, Aung San Suu Kyi, of its most prestigious human rights prize, the Ambassador of Conscience Award. The human rights group said it was profoundly dismayed at her failure to speak out about violence against the Rohingya Muslim minority. Some 700,000 Rohingya Muslims have fled Myanmar due to a military crackdown. Though the UN says Aung San Suu Kyi was not complicit in the violence, she has been criticised for not using her moral authority to stop what the UN has called the genocide of Rohingyas. The Ambassador of Conscience Award is the latest in a string of international honours that the Myanmar leader has lost.
Mark III, the third generation GSLV, inherits various technologies from its predecessors. It's very different in terms of its stages, structure, size, and has double the payload carrying capacity than the Mark II version. Nearly 43.5 meter tall, and with a lift-off mass of 641 tons, ISRO's GSLV Mark III D2 is about to roar once again at the second launch pad at STSC Shar.
Geosynchronous Satellite Launch Vehicle Mark III is the heaviest launch vehicle of India. GSLV Mark III is capable of lifting up to 4-ton mass to geosynchronous transfer orbit or a 10-ton payload to low Earth orbit. This vehicle is powered by two S200 solid motors, one L110 liquid core stage and a powerful liquid cryogenic stage C25. This mission is second developmental flight of GSLV Mark III, and this is important mission for GSLV Mark III program as After this success of this mission, GSLV Mark III will be declared as operational and will join
နမိုးနီးယားရောဂါအကြောင်းသိကောင်းကြရဖြစ်ပါတယ်။ယခုနှစ်2018 World Pneumonia Day ရဲ့ theme ခေါ်တဲ့ဆောင်ပုဒ်ကတော့ Stop Pneumonia နမိုးနီးယားရောဂါကိုရပ်တန့်အောင်လုပ်ကြစို့လို့ဆိုတဲ့ဆောင်ပုဒ်ဖြစ်ပါတယ်။ဒီရောဂါဟာအဆုတ်မှာပိုးတွေတလိပ်တွေထွက်မယ်၊ဖျားမယ်၊အသက်ရှူလို့မကောင်းဘူး၊ရင်ဘတ်တွေအောက်တက်တယ်ဒီလိုပုံစံလေးနဲ့လာတတ်တယ်အဖြစ်များတာကတော့
दिल्ली पुलिस के अफसरों और पुलिस कर्मियों की ट्रेनिंग में सुधार लाने और आधुनिक तकनीक के इस्तेमाल से ट्रेनिंग प्रक्रिया को पहले से ज्यादा एडवांस और कारगर बनाने के लिए नई पहल की गई है। इसके तहत एक नया ई-लर्निंग पोर्टल निपुण तैयार किया गया है, जिसके जरिए पुलिस कर्मियों को कई सारी नई चीजें सीखने को मिलेंगी। अभी अपनी ड्यूटी और दूसरी व्यस्तताओं के चलते कई पुलिसकर्मी और अधिकारी रिफ्रेशर कोर्स या दूसरी ट्रेनिंग में हिस्सा नहीं ले पाते हैं। अब इस नए पोर्टल
की बात है कि 35 साल के सत्यरूप सिद्धांत द्वारा 7 पर्वत चोटियां और 7 ज्वालामुखी शिखर पता कर ली गई है और वे दुनिया के सबसे युवा पर्वतारोही बन गए हैं। कुल मिलाकर भारत के लिए बेहद गर्व का पल है। उन्होंने भी खुद ने यह लिखा कि माउंट सिडली पर भारतीय ध्वज फहरा दिया है, ये बेहद गर्व वाला पल है। पिछले साल ही सत्यरूप ने नॉर्थ अमेरिका में स्थित दुनिया की सबसे ऊंची ज्वालामुखी चोटी भी फतह की थी। कोलकाता में रहने वाले सत्यरूप पेशे से सॉफ्टवेयर इंजीनियर हैं और वे अभी बेंगलुरु में रह रहे हैं। सत्यरूप यूरोप के माउंट एल्ब्रुस, अलास्का के माउंट डेनाली और फ्रांस के माउंट मांक ब्लैंक और किलीमंजारो को भी फतह कर चुके हैं। उनका यह फतह प्रोग्राम बेहद दिलचस्प होता जा रहा है और भारत के लिए यह गर्व का पल भी।
కొనసాగుతోంది. చెన్నైకి తూర్పు దిశగా 540, నాగపట్నానికి ఈశాన్యంగా 640 కిలోమీటర్ల దూరంలో కేంద్రీకృతమై ఉంది. మరో 24 గంటల్లో మరింత బలపడి తీవ్ర తుపానుగా మారే సూచనలున్నాయని ఐఎండీ వెల్లడించింది. 15వ తేదీ మధ్యాహ్నంలోగా పంబన్, కడలూరు మధ్య తీరాన్ని దాటే అవకాశం ఉందని తెలిపారు. తుపాను తీరాన్ని దాటే సమయంలో 80 నుంచి 90 కిలోమీటర్ల వేగంతో బలమైన ఈదురుగాలులు, సముద్రంలో 2.5 నుంచి 6 అడుగుల మేర అలలు ఎగిసిపడే అవకాశముందన్నారు.
ఇంజన్ లేని సెమీ హై స్పీడ్ కలిగిన ట్రైన్ 18 పట్టాలెక్కింది. చెన్నైలో లాంఛనంగా ప్రారంభించారు. దశల వారీగా ఈ రైలును శతాబ్ది ఎక్స్ప్రెస్ స్థానంలో ప్రవేశపెడతారు. రాబోయే నెలల్లో ప్రయోగ పరీక్షలు నిర్వహిస్తారు. ఎన్నో ప్రత్యేకతలు కలిగిన ట్రైన్ 18 ఆకారం బుల్లెట్ రైలును పోలి ఉంటుంది. ఇందులోని సీట్లు 360 డిగ్రీలు తిరుగుతాయి. ఇందులో మొత్తం ఏసీ బోగీలనే అమర్చారు. వైఫై, వాక్యూమ్ టాయిలెట్స్, స్లైడింగ్ డోర్స్ ఉంటాయి. 2 ఎగ్జిక్యూటివ్ కోచ్లతో కలిపి మొత్తం 16 బోగీలు ఉంటాయి. రైలు బోగీలన్నింటిలోనూ సీసీ కెమెరాలు ఏర్పాటు చేశారు. మెట్రో రైలు మాదిరిగానే ఇందులోనూ ఆటోమేటిక్ డోర్లు ఉన్నాయి. ఈ ట్రైన్ నిర్మాణానికి దాదాపు 100 కోట్ల వ్యయం అయింది. చెన్నైలో ప్రయోగ పరీక్షలు విజయవంతంగా ముగించుకున్న తర్వాత ఢిల్లీలో మరోసారి ట్రయల్ రన్ నిర్వహిస్తారు. వచ్చే నెల 7న ఈ రైలు ఢిల్లీకి చేరుకోనుంది. మొరదాబాద్, బరేలీ స్టేషన్ల మధ్య రెండో ట్రయల్ రన్ నిర్వహిస్తారు. ఇక చివరిగా కోటా, సవాయి మాధోపూర్లో పరీక్షిస్తారు. శతాబ్ది ఎక్స్ప్రెస్ కంటే వేగంగా ప్రయాణించే ట్రైన్ 18 గంటకు గరిష్టంగా 160 కిలోమీటర్ల వేగంతో వెళ్తుంది.
Here we are again. Today we are with this problem in which we need to find out the minimum size of plane mirror required in order to a man can see his full height. So let's start from this man. Suppose this man has height h and we put any mirror in front of him, and we will try to find out the minimum size of this mirror so that it can see its full image in this mirror. This man can see its full image in this mirror. This is what we are trying to find out. First of all, we will see that from this top point a ray of light travels to the mirror and reflect back to his eyes. This is the way he sees his head in this mirror. So we draw the lines. Here it is. So we can see this from there his head, this line comes and incidents on this mirror and reflect back to his eyes. And in the same way he will see his feet when light ray travels from feet to the mirror and then reflect back to his eyes. This is the representation of light ray. This is the representation of light ray which is coming from his feet and incidenting on his eyes, and this is the light representation of light ray which is coming from his head and reflecting back to his. We can see that this is the image of this man which men see in this mirror like this. okay, and it will also be of same height as, this is the property of our plane mirror. So we can see this on so this man can see himself as same height in this mirror. Suppose this mirror has suppose we can
होममेड प्रिज्म बनाने के लिए 3 ऑर्डिनरी स्लाइड्स कांच की ये किसी स्टेशनरी दुकान पर मिल जाएंगी। इन्हें चिपकाना है एक ट्रायंगल में। अब प्लास्टिसीन की परत के ऊपर सावधानी से खड़ा कर देते हैं और भर देते हैं पानी। हो गया प्रिज्म तैयार। दिख रहा है ना स्पेक्ट्रम। अब बारी रेडीमेड प्रिज्म की, क्योंकि सवाल है कि प्रिज्म लाइट को बिखेरता क्यों है। जवाब है रिफ्रैक्शन या परावर्तन। जब प्रकाश एक माध्यम से होकर दूसरे में जाता है तो वो सीधा न जाकर झुक जाता है, मुड़ जाता है। अब सफेद प्रकाश एक नहीं अनेक रंगों से बना है और हर रंग की अलग वेवलेंथ, इसीलिए हर रंग अलग एंगल पर झुकता चला जाता है। एक क्रम में सबसे कम वेवलेंथ वाला बैंगनी एक सिरे पर और सबसे लंबी वेवलेंथ वाला लाल प्रकाश